So hemodynamics. What is hemodynamics? Hemodynamics is the study of different forces, different principles that are acting on circulating blood. While blood is circulated through vessels, it interacts or it involves various forces and follows various principles that are studied in hemodynamics. What are these principles? There are four main principles. These are Ohm's law, Poiseuille's law, important for your exam, Poiseuille's law, Bernoulli's principle, and Laplace's law. So all this law, or some of these law, will involve different forces. And what are these forces? Peripheral resistance, blood flow, pressure gradient, energy, vessel radius or diameter, blood velocity, forces, blood viscosity, peripheral resistance. So these are the different forces acting on circulation. Before I start this, one thing you must remember, that the main objective of the cardiovascular system, is to supply blood to the tissues. Why? To supply nutrients, hormones and other required substances necessary for the cells, and also to carry away the wastes produced in the cells. Okay? So this is the main purpose, to send, and this will be done through the blood. Blood will do these functions. Now, how blood will go there? Blood has to go through the tissues, and this blood will go through a circulatory system. Blood will go there through this system, and the heart is the pump that will act as the driving pressure for the blood to go to the periphery, to the tissues. Now, if we study the blood pressure in the aorta, it is how much? 120, normally it is 120 millimeter of mercury by 80 millimeter of mercury, systolic blood pressure and diastolic pressure. But if you proceed along the blood vessels, what you will find? Pressure gradually falls. And ultimately this pressure and in the capillaries comes down to near about 40, 50. Okay? So from there, it is coming down to this value. How? How it became possible? How it became possible? Because in the aorta, that the left ventricle pumps its blood into the aorta during systole, and during systole the pressure in the aorta is 120 milli, and that is the maximum pressure. And here in the aorta, if you get the cross-sectional dia, if you get the cross-section of the aorta, you will get a cross-sectional diameter. And this cross-sectional diameter, what will happen? This aorta will produce branches, and these branches will be producing again branches. Now the smaller arteries will be producing again branching, ultimately capillaries will be formed. As a result, what will happen to the total cross-sectional area that you observed in capillaries? If you get the cross-sectional area of each and every capillary and you sum it, will it be more than or less than the aorta? More. As a result, what happens? Blood pressure gradually falls. The amount of blood that the ventricle is ejecting every minute is 5 liters, which is, we call it a cardiac output. The same amount of blood is going to different parts of the body, different organs of the body, and these 5 liters of blood are distributed throughout the body. Again, this amount is coming back to the heart. So, during this process, what happens? What I wanted to tell you, that gradually in the circulatory system, starting from aorta, gradually cross-sectional area becomes increased. As a result, what happens? Blood pressure is lowered. Okay, so what is the relation between cross-sectional area of the vessels and blood pressure? What is the relation? Okay, so that you must remember. Another thing, these vessels we classify into 4 types. We classify these vessels into 4 types. What are these? One type is Windkessel vessel. One type is Windkessel vessels. Aorta is the example. Bigger arteries are the example. Here, if you study the wall of these vessels, what you will find? The wall is thick. And their outermost layer is made up of collagen and elastic tissues. Collagen and elastic tissues. As a result, they show high elasticity. They show high elasticity. They are very compliant to pressure. Means, if you exert pressure, they will be distended. Okay. Why this pressure? Because some amount of blood has entered into the vessel, so they must be accommodated within the vessel. How they are accommodating? By expanding. By expanding. Okay. So now when contraction is over, systole is over, diastole began, then what will happen? The valve will be closed. No blood will be entering into the aorta. No blood will be entering into the aorta. Now what will happen to this blood already entered earlier? The aorta has been expanded, no? Now because of their elasticity, they will be coming to its original position. As a result, pressure within the vessel will be increased, and where it will go? Then it will move forward. It will move forward. So, this sort of activity of the vessel is seen in Windkessel vessels. In aorta means they will expand and again they will contract. Because of this, the blood will be going forward. Okay. That's why we see even during diastole, blood is continued to flow. Okay. Another type of vessel is, we call resistant vessels. Means they can produce resistance. Resistance means badha. Okay. Bangla amra jetake we can all are Bengali students. So badha. So kishe badha? While flowing, again, they create this resistance. Some vessels, they can create this resistance. How? We know the wall of the vessel is also made up of muscles, tunica media, made up of smooth muscles, and these muscles are under the neural control. More specifically, under the sympathetic control. These smooth muscles are always remain in a tonic contraction state. Means sympathetic center of the medulla, vasoconstrictor area of the medulla, also called vasopressor area, they send efferent nerves to these vessels, and always they secrete some sympathetic neurotransmitters. What are these? Noradrenaline. Okay. So because of this hormone, this action, the smooth muscle remains contracted to some extent, not fully, to some extent. These vessels remain in a partially constricted state. So vasoconstriction means resistance. Okay. So now you see, there is a condition in my body, blood pressure is increased because of vasoconstriction or because of increase in heart rate, increase in cardiac output. Now I have to lower the blood pressure. How it will be done? This sympathetic control tone will be withdrawn. Means this center will be inhibited. They will not be sending any impulse to the blood vessels. As a result, the blood vessels will be dilated. Means low resistance is lowered. So now blood can flow easily. So no pressure. No extra pressure now. Blood pressure will be coming down. Okay. The opposite you think. Blood pressure became very low. So my pressure has to be increased. My purpose is to make perfusion, tissue perfusion adequately. So for that purpose, my blood pressure has to be increased. Now what will be done? This vasomotor area will become activated and it will send sympathetic impulse to these muscles. Now they will be contracted, pressure will be increased. So in this way, these muscles, these vessels, those who are having these smooth muscles, by contracting and relaxing, they can increase the resistance, or by decreasing or dilating, they can decrease the resistance. So these are small arteries, arterioles. These are actually small arteries and arterioles. Minor change in their diameter can cause a major change in blood pressure, in blood circulation. So by this way, by increasing and decreasing the diameter of these vessels, how? By increasing or decreasing the resistance to flow. If blood vessel is constricted, there will be increased resistance. So blood pressure will be increased. If it is dilated, vasodilatation is there. When these vessels are dilated, then the resistance will be less, so blood will be passing through easily, blood pressure will be less. So for performing this type of function by these blood vessels, as they are perform this type of function, they can create resistance. Okay, by their sympathetic activity from the vasomotor area, they can increase the resistance. That's why these vessels are called resistance vessels. So it is the resistance vessel only that create, that lower or increases the blood pressure. What are these vessels? Smaller arteries, arterioles. They are these resistant vessels. Another type of vessel is there that is called exchange vessel. What are these exchange vessels? Capillaries. Here pressure is minimum the pressure here we call it hydrostatic pressure. And because of the hydrostatic pressure and osmotic pressure, the exchange of fluid takes place in between intracellular, extracellular fluid and the blood. Okay, so some fluid will be come out because of this hydrostatic pressure, increased hydrostatic pressure. Because of this, what will be some fluid will be coming out of the blood vessels, capillaries into the intracellular, and it will bring the necessary substances for the cells. Now the cells will get it from this fluid and it will excrete the unnecessary waste products into the ECF. From ECF again some fluid will be, some ECF will be again absorbed because of this one pressure, what is this, Stalling forces. So you have idea regarding Stalling forces? So you must have, because you may face some questions from here. What are the Stalling forces? State is true in development of edema or fluid exchange. Exchange of fluid exchange in the capillaries. Okay, so this sort of you have to explain this Stalling forces. So these are the exchange vessels. Another type of vessel is there. What is this? Capacitance vessels. And these are veins. Capacitance means they are very much distensible. By applying less force, you can distend them more. Okay. Their wall is also made up of muscles. So they are also having sympathetic control. So when sympathetic nerve stimulates these muscles, these veins will be contracted. So the blood will be coming back to the heart, means venous return will be increased. Increased venous return, increased cardiac output, increased blood pressure. So whenever we need to increase the blood pressure, what will happen? These capacitance vessels will contract and this additional blood will be coming back to the heart through cardiac venous return. Then since venous return is increased, we know increased venous return means increased stroke volume, means increased cardiac output, means increased pressure. Okay, and another important thing, out of 5 liters of blood, which will contain more, either the arterial system or the venous system. Out of 5 liters of blood is ejected, this 5 liters will be circulated, no? Arterial system, venous system. Now, maximum blood you will find in the venous system. Out of this 5 liters, near about 3.5 liters of blood you will be getting in the venous system, and the rest you will find 1.5 liter in the, even less in the arterial system. Okay, so this is the reserve actually. So whenever we need, when we do exercise, we need more blood. So then whatever is this venous system constricts and this blood has to be circulated throughout the vital organs like brain, heart, muscles. So this extra blood is circulated throughout the body so that vital activity can be performed. Okay. So with this knowledge, now we are proceeding further. What is this? We will be studying the interrelationship of pressure, flow and resistance. And we will find, we told already, that the circulatory system follows certain principles. One is Ohm's principle, Ohm's law. Ohm's law, we know it is applied in case of electricity, current. I is flow of current. I is equal to voltage by resistance. Okay, you know it. So this is the Ohm's law. Now this Ohm's law can be applied in circulations also. Flow. Instead of I, we will be using Q, means flow, means F. Flow, blood flow. And it is equal to what? Instead of voltage, you will hear the pressure difference. We know blood flows from higher pressure to lower pressure. How much blood will be flowed? It will depend on the pressure difference. So that is the pressure difference by the resistance. Resistance created in the periphery. Resistance created in the blood vessels. The resistance created in the blood vessel not only by the diameter of the vessel, we will be knowing there are some other factors too. So in the vascular pressure difference, so here we can so this is the Ohm's law. I is equal to V by R. V is electromotive force, means voltage difference. R is the resistance. If in the I can replace this with this. Instead of I, we can flow, and instead of this V, we can replace it by pressure difference, and the R is the resistance. It is common. So we can see Q means flow is directly proportional to pressure difference. Higher the pressure difference, higher will the flow. Okay? And higher the resistance, less will be the flow. So this is inverse relation. Higher the resistance means higher vasoconstriction, less will be the flow. Okay? So this is the thing. Though this is the tube through which blood is flowing. Another factor is there. Length is also an important factor. Is more length, more friction will be there. When it will be flowing, blood will be flowing, liquid it will face more friction, means there will be more resistance. So length is also a factor that can create resistance. And diameter is having inverse relation with the flow. Higher the diameter, more will be the flow. Lesser the diameter, what will be less will be the flow. Now let us discuss the blood flow. We'll get blood flow is of two types. In a tube, blood flow can be two types. One is laminar, another is turbulent. Let us say when turbulence is normally it is laminar. Laminar flow also called streamline flow. In laminar flow, blood flow flows in layers, concentric layers. So these are the layers of blood. This is the outer layer and this is the innermost layer. And it forms a parabola. While flowing, it forms a parabola. Why this parabola? Because this layer, the outermost layer faces more friction while it flows. It faces more friction because this is fixed, this is moving. As a result, this layer here, the components of the blood faces friction. Okay, as a result, the flow of this layer becomes less. Whereas this layer, for this layer, this is partially moving. As a result, here friction is relatively less than this. So its movement will be relatively faster. Its flow will be relatively faster. And the central layer, it will be having minimum resistance. As a result, it will proceed ahead of others. Okay. So this layer, central layer moves fast. And the other layers, their movement is it will be dead. As a result, this parabola is formed. One important thing you remember, either you may face short question or explanatory question. What is this? This is blood, no? Blood is having cells, RBCs. Now these RBCs, cells, are all cells. Most of the cells are accumulated in the central layer. If you take blood from this central layer and analyze it, go for hematocrit, you will find the hematocrit value. What is hematocrit? Ratio of cells to plasma. Here, in relation to plasma, cells are more. And if you get hematocrit of this layer, you will find their plasma is more, cells are less. And this phenomena is called blood skimming, S-K-I-M-I-N-G. What do you mean by blood skimming? Now you see, from these vessels, one branch came out. From these vessels, one capillary is formed. The smaller branch is formed. Now, this capillary will get blood from this layer, isn't it? And if you take out the capillary blood and analyze for hematocrit, you will find the hematocrit is relatively less. Okay. Then, if you collect the blood from a large artery, large vein, then you find a hematocrit. Here, hematocrit is more, but in capillary it is less. Why? The reason is plasma skimming. Plasma skimming. While it flows, while the pressure flow is laminar. Importantly, the laminar must be, flow must be laminar. Flow must be laminar. So when laminar flow is made, peripheral layer, the blood cells are redistributed. Means centrally the blood cells are more, peripherally blood cells are less. So when a blood vessel is originated, smaller vessel is originated, it gets this blood, peripheral blood. So this blood is having less cells, means low hematocrit. Is that clear? This point to you? So remember this. So this is laminar flow. Okay. Now let us discuss the laminar flow occurs in long straight blood vessels under steady flow conditions. Laminar flow is the normal condition of blood flow throughout most of the circulatory system. Okay, normally it is laminar. But when a blood vessel is bifurcated, large blood vessel, it is bifurcated, one condition. Or a blood vessel, at the center, there is, in some part, there is a narrowing. Bifurcation. Narrowing of the blood vessels, constriction. Why this constriction? Atherosclerosis. Because of atherosclerosis, this sort of constriction may be there. A constriction. Constriction takes sharp turn. Rough inner surface. The inner surface is rough, as happens in atherosclerosis. Decrease in viscosity. Remember these 2 points. Viscosity of blood can be increased or decreased. In polycythemia, what happens? What is polycythemia? RBC count is increased, more blood cells. So, more blood cells, will it make blood viscous or less viscous? It will make blood thick, isn't it? Means it will make the blood viscous. And viscosity means more blood will be, there will be increase in viscosity because of polycythemia. As a result, what will happen? Resistance will be increased. Increase in viscosity, increase in resistance. Now think, in anemia, when viscosity is increased, the resistance flow will be reduced. Flow will be reduced, velocity will be reduced. Isn't it? When viscosity is increased, resistance will be more, pressure will be more, flow will be less, and velocity will be less. But in case of anemia, you may see the opposite things. Means here, red cells are very less. As a result, blood becomes thinner. Means its viscosity is less. Means blood, it is viscosity, as I said, is a resistance, means less resistance. So less resistance, more flow, more velocity. So when velocity is increased by any condition, this will, here, the flow will not be laminar in such case. Here, when the blood will be passing through this constricted area, here flow will not be laminar. Now what will happen to these concentric layers? They will be disturbed, dislodged. As a result, the constituents of the blood, they will show haphazard movement and they will continue to make friction with one and another. And this is called turbulence. And this creates a chaos. And this chaos produces a sound. If it happens in a blood vessel, we call it, this sound we call it bruit or murmur. This sound is called bruit or murmur. While you will be measuring the blood pressure, here the artery will be occluding totally. Then by releasing the pressure, cup pressure, you will be gradually releasing. Then what will the occluded vessel will start to open. Now the diameter is very less. As a result, what? Velocity will be more. And this increased velocity will produce turbulence. As a result, you will hear a sound. And when gradually blood vessel, the vessel artery becomes fully dilated to its origin, now the flow will become laminar. So no pressure, no sound you will hear from here, from this area. So that will indicate the diastolic pressure. When you started hearing the sound, the correct cuff sound, it is the systolic pressure. So what happens? Here in turbulence, a flow is said to be turbulent when the laminar pattern is lost. Here the molecules move in different directions and collide with each other. So there is mass loss of energy. It occurs when rate of flow exceeds the critical velocity. Means when the velocity of flow, because of narrowing, because of this or rough surface or sharp turn, because of this, what happens? Interruption or obstruction of blood flow. A turbulent flow produces sound or murmur, and these sounds can be heard over it with the help of a stethoscope. Sounds due to turbulence not normal in arteries. But if you find a sound, a bruit in the arteries, then what is there? immediately there is some narrowing, and it may be arteriosclerosis. It may be due to arteriosclerosis. Okay, or thrombosis. Probability of thrombosis. That means it may create thrombosis. So, this is turbulence. Now, you can predict whether the laminar flow will be turbulent or not. My blood flow can, whether it become turbulent or not, that I can predict using a number, we call it Reynolds number. Question. What is Reynolds number? You have to explain what is Reynolds number. What is the relation between turbulence and Reynolds number? Okay. A dimensionless number that predicts whether the flow will be laminar or turbulent. It is influenced like factors. What are these factors? Remember, one is velocity. Higher the velocity, higher the chances of turbulence. Vessel diameter. Lower the vessel diameter means inverse relation. Lower the vessel diameter, higher will be the resistance, higher will be the velocity. So, chances of turbulence will be more. Blood density. I am to explain, already explained. Blood density, blood viscosity. When there is polycythemia, density, viscosity is increased. When there is anemia, it is reduced. Okay. So, what are these? There are various factors which determine whether the blood flow will be turbulent or laminar. What are these factors? One is density of the fluid, velocity of the fluid, diameter of the vessels, and viscosity of the fluids. Now there is a Reynolds number Re. It is what? Internal forces divided by viscous forces. What are these internal forces? The first three are the internal forces. Density of the fluid or blood, velocity of the blood, and diameter of the vessels. So if it is like this, what is this? The density, velocity, and what is D stands for? Diameter of the vessels, and this is the viscosity. Okay, from this relationship, so you must remember this. So, see, what is this? Viscosity is inversely related to this. And these are directly related to this. Okay. So, whenever this value is increased, velocity increased, Reynolds number will be increased. When the diameter is increased, Reynolds number will be increased. D for this small d for diameter of the vessels, and this is having inverse relation. Now this value, if you put this all these four values and the Reynolds number becomes 2000, below 2000 or below 2000, that means that will indicate the flow will be laminar. And if it is 2000 to 4000 in this range, that is, it is in the process of, in transition for producing turbulence. When it exceeds 4000, definitely there will be turbulence, and you will be going to hear in the affected area, you will be hearing the sound. When there is decrease in the cross-sectional area of a vessel, as in stenosis, it happens as stenosis, calcification in valves. So narrowing, there will be narrowing of the opening. So narrowing means there will be increased velocity, so murmur will be produced. So you can see the murmur, hear the murmur. Now, another important, very important question, Poiseuille's law. This law, so we have studied Ohm's law, isn't it? Then we are studying here the Poiseuille's law. Poiseuille. Poiseuille's law. This law describes the relationship between blood flow, radius of the blood vessels, length of the blood vessels, viscosity of the blood, and pressure difference along the blood vessels. So what are these? 5 factors. Blood flow, blood pressure, means pressure difference, then radius of the blood vessels, and viscosity of the blood. Viscosity of the blood. Now how this is expressed? This is expressed as this. Q is the flow. Q is the flow of blood. And pi r to the power 4, it is the radius of the blood vessels through which blood is flowing. Radius of the blood vessels, 4th power. And pressure difference. Pressure difference. Suppose this is the blood vessels. So from here to blood is coming to here. So what is the pressure difference? It's definitely this will be higher pressure. This is the lower pressure. So what is the difference? Delta D, delta P. So higher the delta P, higher will be the flow. Okay? Higher the radius, higher will be the flow. And what is this? This is blood viscosity. And it has got inverse relation with Q. Inverse relation with Q means higher the Q, low will be the flow. Low the viscosity, higher will be the, we have already studied it. And length also inverse relation. Higher the length, more resistance, less flow. So this is the relation by which we can interrelate vessel radius, pressure difference, blood viscosity, vessel length, and flow. So from this, what is the clinical relevance? If there is a vasoconstriction means this is lowered. If it is lowered, what will be? Constriction. If it is more, if vasoconstriction, R is lowered, R becomes less. Okay, then what will resistance will be more. And this increased resistance will reduce the blood flow. Vasodilatation. This R diameter is increased, so resistance is less and there will be increased flow. Polycythemia. In polycythemia, what happens? Viscosity increases. As a result, blood flow will be decreased. In severe anemia, what happens? Viscosity is lowered. As a result, blood flow will be increased, but velocity will be increased. There may cause turbulent and produce fluids. So in anemia, there is a chance of hearing fluid. Right? From this Poiseuille's law equation, we can derive this. If the L is doubled, in this equation you double the L value, then what will happen? The flow will be reduced to 50. Will be reduced to 50. Normally it is 100 ml per second. This is the flow rate. Okay. So now it will be reduced. Now if you double the viscosity, again flow is reduced. If you double the pressure, what happens? Flow is doubled. Flow is, because since it is having direct relationship, and double the radius, see, That's why we tell, by changing a little, if you change a little the radius of the blood vessel, there may be huge change in blood flow. Minor change in blood vessel radius, major change in blood flow. So this is actually done by the nervous system. By this, it increase, decrease. By diameter increasing, decreasing, it can control the blood pressure. It can control the blood flow. 90% increase in radius will double the volume flow rate. Now, this equation, you replace Q. We know in the Ohm's law, what we learn? Q is equal to delta P by R. So in Poiseuille's law, instead of writing Q, we will be writing delta P by R. Okay, right? Then again, instead of Q, write delta P by R. And rest of the part of the Poiseuille's equation will remain same. Now from this equation, you derive the value of R. You derive the value of R. Now you will find resistance depends on what? And how these factors are related to resistance. What are the factors? You may face questions or MCQs. So these are the factors. Out of these, following are related, except one. Following are related to resistance, except one. So this sort of MCQ you can face. You will get this value, isn't it? Did you get this? You will get R is equal to 8 L means length of the vessel, and this is the viscosity divided by diameter of the radius of the blood vessels. So you can see the relation between this and this. What type of relation? Direct or inverse? And these are directly related to this. So these are the factors: length, viscosity and diameter. Now viscosity again is dependent on composition of the blood. Viscosity of blood is dependent on composition of the blood. So in a condition there is increased plasma protein. As a result, what will be there? Increased viscosity. So resistance will be increased. So this is the condition. In such condition, resistance will be increased. And increased resistance means what will happen to the flow? You know that. Another thing is blood cells, already discussed. In polycythemia, in anemia, what happens to viscosity? In anemia, viscosity is less. In polycythemia, viscosity is more. So they will have this viscosity. If it is more, resistance will be more. If it is less, resistance will be less. So these are the relationship. This polycythemia, this question comes. Polycythemia, relation of polycythemia or anemia to resistance. Okay, now another principle or law, that is Bernoulli's principle. And this principle states the relationship between pressure and velocity. Pressure and velocity. change in pressure in a hydraulic system changes the velocity of the fluid movement. Change in pressure will lead to change in velocity. This pressure are of two types. One is lateral pressure, another is dynamic pressure. And this Bernoulli says what the sum of these two pressure is always constant. It will never change. Sum of dynamic pressure and sum of lateral pressure will remain same. Okay. So if lateral pressure, if dynamic pressure is increased, lateral pressure will be reduced. If dynamic pressure is reduced, lateral pressure will be increased. This is the relationship. Now you can see total pressure, it is equal to kinetic total pressure, it is equal to kinetic, or means dynamic pressure, and PE means it is the potential or lateral pressure. Okay, so kinetic pressure, here it is kinetic pressure equals to half P V square, where P is the density and V is the velocity. So in normal blood vessel, V can be negligible. In that case, what happens the equation? T is equal to PE. So it is ignored. But what happens? So study this. This is a vessel. Suddenly it has become narrowed. It is constricted. Okay. So now I want to measure two pressure. One is dynamic total pressure, another is lateral pressure. So this is the pressure gauge. These two are pressure gauge. One pressure gauge, this will measure the lateral pressure, and this will, so blood is flowing in this direction through this pressure gauge is, the opening is facing to this direction. As a result, it will be measuring the total pressure. It will be pressing the total pressure. So TP means level of T. See here, up to this is the total pressure. And out of this total pressure, lateral pressure is this much. Now when the blood is entering from here to this narrow region, what happens? Velocity increases. Because of increase in velocity, what happens? The lateral pressure comes down and potential and the dynamic pressure increases. But the level of the total pressure remains same. So what happens when there is narrowing of the blood vessel? Lateral pressure means perfusion pressure becomes down, becomes less. Otherwise, the capillaries would have been what? There would have been tearing. Okay. So here what is the situation? Low velocity, high pressure. Here high velocity, low pressure. So when velocity is high, it causes increase in velocity. So it will create the less pressure, less lateral pressure. Again when it enters in the dilated portion, again the lateral pressure increases. So this is the relation. Laplace law. Okay. You studied, it is less important.